Alright, forgive this unorthodox setup. This is more just to move my camera around, but let me introduce myself. My name is Galvez-Vega. This is my final project presentation. So the dataset I chose is from Kaggle. It's called Spaceship Titanic. Now, unsurprisingly, in this fictional year of 2912, out in the galaxy as a ship is exploring habitable planets outside of our solar system, unfortunately, because it's called the Spaceship Titanic, it ends up running into a space-time anomaly, screwing all intentions up. Now, 13,000 passengers were originally aboard, half of them disappear. The objective of this particular data set is to determine who managed to keep aboard, who didn't, based off the features. Just here. I'm going to look over here for a second just because I have a few notes here, but don't let me confuse you. Passenger, home planet, cryosleep, cabin, destination, age, VIP, room service, food court, shopping mall, spa, VR deck, name, and transported are the columns of this data set. Now, some of them account for like how much spent, like room service. Some of them account for whether they're in cryosleep and where they're planning on going, the planet they're originating from. There was over 8,000 rows. Per the instructions, I separated 50. There was a testing data set already existing in Kaggle, but I didn't use it, and I just stuck to the training data like instructed. Those 50 were the cleanest examples I could find that had no missing data or anything like that. From there, I moved on to trying to clean up the rows that existed. First, I took out two columns, passengers and name. They didn't really provide anything of significance for the data set, and I added a column called row just to have an initial number count based on the data set while I was cleaning everything. And from there, some other things that I ended up removing. I tried to remove any missing values from room service, food court, shopping, spa, and age. I replaced any of the numerical values with a mean because they're continuous numeric values. And then with cryosleep, cabin, destination, and VIP, I replaced them with a mode since they were categorical values. With transported, I ended up just deleting any missing rows because that's the target variable, and I didn't want to risk anything. There was a special situation where I had to reduce a column early, particularly cabin, because there was 30 categorical types, and apparently Excel does not enjoy that. So I reduced it down to 15. They got combined into 15 options instead. And from there, I created the dummies. Now, strictly, I don't think this was completely necessary in most situations because models in Excel can be placed into a categorical area. But because we're using principal component analysis in this situation, it made more sense to segment everything. So the PCA could determine what features were important. So VIP and cryosleep were already automatically set when I was handling the missing data values, but destination and again column were adjusted, and I'm going to show over here. You can see right here the columns that were created out of it. So onto data exploration. I checked the scatter plot matrix to see if there's any other columns I could remove, because anything with a strong correlation, positively or negatively, one of the columns gets opened up to for removal potentially. But I didn't see anything like that. The data seemed pretty clean, so based off that, I ended up just moving on to the next part. I did a principal component analysis using Excel. I found the top 5, which ended up being Cryosleep, Home Planet Mars, Home Planet Earth, Cabin 15, and Destination TRAPPIST-1E. Based off this, I also got the top 15 because I wanted to include a separation of the model of just using the top 5, top 15, and then just all of the data. And I ended up choosing a logistic regression approach. Now, why did I choose this? Logistic regression can be used for multinomial classification, but it's phenomenal when, for binary classification, which this is because the data set, the transported target variable, is either transported or not. Some other things about logistic regression that's incredibly useful is outside of the fact that it can be used for a diverse amount of things like predicting low defaults, determining spam, checking for diseases. It's great for, it can be used to add regularization with these models to avoid overfitting. And it shows probabilities of the predictions, unlike linear regression, while still being lightweight compared to other algorithm options. And it can be used for, you can throw in a bunch of historical data, which is obviously useful for predictions that are supervised learning focused. My best model ended up being 5. I split of the original models. There were 6. I split them up between the top 5 PCA, the top 15 PCA, and the last 3 were included all the data. And then from there, the partitioning was just 70-30 training to testing, 60-40 training and testing, and 50-50 training and testing between the PCAs and then between the complete. Now, the PCA models actually did pretty well. They had a 70% accuracy score in general, low 70s. But the models with the complete data obviously did a little bit better. They jumped up by about 8 points, and Model 5 had a good mix of training accuracy, low training error, and keeping a precision and recall that was, I thought, worth using. The results ended up still remaining within the 78 to 79% range, and I'm going to include an observation that they did particularly well with large groups that were of the same type. With the classification trees, that's the model that I chose next. Now, why did I choose this? This is also great for binary classification. And unlike a lot of other model options or algorithm options, this is very visual. You oftentimes get a tree that you can see exactly how things are split up. So it's very easy to interpret from the researcher/experimenter side. The height can be adjusted if you want to change the complexity. You can prune the tree if you want to remove anything unnecessary. And like logistic regression, it's good at showing high probabilities of whether a patient has a disease, determining customer behavior based on purchase patterns. It's used for all sorts of stuff. Now, it did a little bit less cleanly when it came to the models that were using all the data. They were still within the 78% range, but the testing decreased by like a point. But the PCA models actually did a little bit better. They were still in the low 70s, but they also moved up by a point or two. Model 5, hilariously, in this case, was also the best model. And it also resulted in a 78 to 79 range when predicting using the testing set. Now, just to show the diversity of these algorithms, I'm going to talk about 2 case studies really briefly for logistic regression and for classification models. So, the first case study is modeling student performance in mathematics using binary logistic regression at selected secondary schools, a case for Medwar municipality at Yalma district. The reason I chose this model, this case study particular because I found it interesting because it focused on education. Now, apparently in Tanzania, Tanzania. Apologize if I'm mispronouncing that. Linear regression, logistic regression is not used. In this case, logistic regression is not used commonly. I meant to say models aren't used commonly for predicting how things are performing. And this article was an argument to do just that. So they got 250 students from a particular area, and they focused on mathematical performance in particular. Half of the students were male, half the students were female, and they set up a bunch of features: performance, which was a target variable, misconduct, gender, school type, and absenteeism. Now, they were able to find, with a decent margin of accuracy, a performance change, particularly whether someone was prone to misconduct and whether they attended classes frequently. It had a base, I'm looking over here just to look at my notes, I'm not trying to stare away, a 77.6 accuracy score overall. And it ended up really showing just how vital attending class and how conduct versus misconduct ever plays a role in mathematic performance. Now, the other case study in application of logistic regression and banking lending, a machine learning perspective, completely different area, and I thought that was it really shows like you use this in a lot of places. Was specifically for trying to predict whether someone's likely to default or not default based on bank lending. This paper was more an argument of just using logistic regression, even though there's more advanced models that exist, because it's these models are very simple, but they still remain efficient in comparison to bulkier model options. They, like I mentioned before, produce probabilistic outputs where you can get like a real good gauge, and it's easy to interpret just because of their nature. Now, with this, they've focused on a variety of things, including like income and other aspects, and a lot of times it was showing that like the accuracy still remained quite high, 80%, despite being a more simplistic model. And the benefits of using something like this, despite having like it's not the greatest for nonlinear relationships, and class imbalances can mess with it a little bit. The benefits, though, still outweigh the risks, because I mentioned regularization, the fact that that is deployable plays a significant role, and if you focus on upgrading these particular aspects, it makes it a much more viable option in particular. Anyway, let's move on to the last two. So another area which was interesting was forecasting. In particular, this study, the use of classification trees as a tool for forecasting avalanche activity on Seward Highway, Alaska. It focused on the stretch of road from Seward to Anchorage. And they used historical data. So like I said, supervised learning, whatever, when you have historical data, it could be potentially very, very useful. And they had over 3 years of records on avalanches. So they put this to work. They separated 552 avalanche days and 387 non-avalanche days for a total of 939 days analysis. And then they went to work focusing on temperature changes from 24-hour standpoint, 48-hour standpoint, 72-hour standpoint. There was focus on wind and how much the road was covered overall. And yeah, high temperatures ended up showing a significant high temperatures and water input in particular ended up showing a significant role in determining the avalanches of the road and how heavily the road ended up covered. And another interesting fact is they seen, because a secondary focus of this endeavor was to see whether this could be carried over to other areas, and they found that certain meteorological triggers do seem to be able to be used in a more generalized sense. The last study, and just to reiterate over, these are all very different use cases for these algorithms, so there's really a lot of application value depending on like how you want to mess with any of this type of stuff. The last one is called churn predictions in the telecommunication industry using decision trees. Now, what is churn? That's basically when a customer switches from one provider to another. They wanted to show that these trees are useful, decision trees are useful to determine this sort of stuff. So they took 33,000 customers that were like a mix of active and non-active, and they ended up creating multiple trees. That's another benefit of like decision trees. You can do a mix, and they were able to find with a 87% to 90% accuracy score whether like a customer was likely to basically back out or not. And this paper is also focused on trying to show like how decision trees are still like a useful use case for an area such as this, and how they can be taken advantage of to try to promote customer loyalty. And so I think I'm at the 15 mark, but here are my references. Feel free to check out any of the articles you want. They're actually pretty interesting. And I also used some general references from sites that don't require ownership over the pictures, and just general searching when finding all this information. Thank you very much. Have a good day.